Hello everyone. We are project team number 18 of ISD 528 designed for manufacturability and our team constitutes of 5 members, Emil, John, Mark, Mike and Sarthak, that's myself. Going next, we have agenda. This is the agenda sheet. These are the topic that we are going to through this presentation. Next, we have team members and their roles and responsibility distributed among them. Going next, we have product description. Our product is meat grinder, and as we know, the operation of meat grinder is as simple. We have to take the meat through the inlet plate where it will travel down to the funnel, and it is then fed into the chamber with a screw conveyor, which is powered by electric motor. Our primary users will use our machines for chopping, mincing, or mixing raw ingredients such as meat, vegetables, and animal feed. Moving on, we have assembly view. Mark will go take us through that.
Thanks, Arthik. So in the finished assembly view for the end user, what we have is a lot of the functional components that are captured on the inside with the exterior protecting most of those components. When we expand this out to the exploded view, we confirm that and notice that most of the functional components directly interface with the meat itself. Now I'll turn it over to John.
For the meat grinder, we have two main groups. Our primary customer group, which is commercial grade kitchens and restaurants who process high volumes of meat, and the secondary group, which is smaller businesses and individuals. So moving on to the fast diagram, we identify the primal functions of the meat grinder to be intake food, processed food, and output food. And similarly, we've looked at the higher level functions that follow those. Mike.
Thanks, John. Based off the design that Mark briefed, we created two assembly sequence diagrams, then performed our assembly sequence analysis. Assembly sequence 1 focuses on assembly of major subsystems in parallel, then integrating it into the entire system. Assembly sequence 2 focuses on a bottoms-up assembly approach, starting with a base and limiting the amount of time you have to manipulate the entire system during assembly. For our assembly sequence analysis, assembly sequence 1 beat assembly sequence 2 by a score of 10-8. Sarthak?
Thank you. Next, we have function component mapping matrix. In this table, we have all the functions placed at the top of the table, whereas on the right-hand side, we have all the parts. And as we can say, for example, we have rubber leg, which is mapped to improve stability. Its function is to give stability to the part. And likewise, we have mapped all the parts to their respective functions. Moving on, we have bomb coming up, which will be taken care by John.
Okay, so this is our BOM. We've estimated our total production cost to be $532 per unit for a 50,000 unit per year batch size. We have three main manufacturing processes used to make the meat grinder: injection molding, machining, and sheet metal bending. And we've also sourced some parts that won't be fabricated. Moving on, I'll go over the assumptions that we use to create this BOM. The main one being we assume some operator and CNC operator costs per hour. We assumed some assembly times for each part, assumed machining time for each part, and assumed some material costs based on the volume and mass of each part with some scrap costs. Moving on to the DfMA focus analysis, we created the chart that shows the manufacturing costs and high functional importance. 4 parts came up in that area, which were tube, motor base, and inlet plate. These 4 parts will be analyzed using DfMA moving forward.
Here you can see our functional differentiation table. From our fast diagram, we took these functions and divide them up between what we thought was going to be the same for each customer and what was going to be different for each customer. For different, we thought shape food enabled disassembly, add versatility, and improve stability. We then used these to come up with the component commonality table. So on the left, you can see our platform for all customers and our modules for our individual customers, such as rubber leg, inlet, conveyor screw, just to name a few.
So now we look at the visual representation of the common interfaces that Emil had just mentioned, and then we move into the product variant component differences, which overall map back to the functions that are unique between the different variant groups. So we have the motor and the inlet plate, which overall allow for better versatility. Then we have the grill, the knife, and the screw, which allow for better versatility. And then finally, we have the rubber leg and the tube close ring.
Lastly, you can see the differences between our original a winning assembly sequence and how we modified it to increase the efficiency. We essentially took those unique parts and moved them towards the bottom of the assembly to increase the overall efficiency of the assembly sequence. And for summary and path forward, like mentioned earlier, the tube, motor base, and inlet plate are going to be focused on for DfMA focus analysis, and our paths forward are going to include mature BOM, explore more efficient manufacturing, and identify opportunity for part consolidation.